So distance on a graph. This is a little bit more visual and helpful for us than what we were doing yesterday with the distance formula. And I kind of already introduced you guys to this idea with the little drawing I did up on the board. Remember, you and your friend's house, you can't just walk through the neighborhood. You got to go down the street and then turn right. Remember that from yesterday? Okay. So that's essentially what we're doing here on this little map. It's a graph, but I won't call it a map, right? I'm trying to get from point A to point B. Now, all these little squares are people's houses and front yards and backyards, so I can't just walk straight from A to B, but I do want to find how far is the direct distance from A to B, all right? So in order to do that, I've got to go down the street, turn right, and then I'm going to go down that other street a little bit, all right? So very easy steps here. Starting at either point. Obviously, point A, I'm going to start at point A. We're going to count the number of spaces up or down, which is my vertical distance. So if I'm going from A to B, does it look like I'm going to have to go up the street or down the street? I'm going to have to go up. From A, I'm going to go all the way up the street, and I'm going to stop at 8 because that's what lines up with point B right there. How many spaces up the street did I just go? Go ahead and count those squares real quick. How many spaces up did I go?
12.
12. Very nice. So right next to that line, we're going to write 12. So imagine I'm starting at point A, I'm in my car, I'm driving up the street, I go 12 blocks up the street, and then I got to turn right. Okay, that's where my horizontal distance is going to come into play. This time I'm turning right, and I'm going all the way over until I end up at my friend's house, which is point B. Now, how many blocks to the right did I have to go after I turn? 5. 1, 2, 3, 4, 5 blocks. Means that my horizontal distance is 5. Vertical distance 12, horizontal distance 5. So what we just did is the exact same thing as doing y2 minus y1 and x2 minus x1. If I look at my x's, my x coordinate here is 8. My x coordinate there is 3. What is 8 minus 3? 5. If I look at my y coordinates, I've got 8 and negative 4. 8 minus negative 4 turns into 8 plus 4, which is what? 12. So we're kind of doing the same thing as we did in the distance formula, but a lot easier because we're visualizing it and all we're doing is counting. We don't have to worry about what we're plugging in where. We're just getting these two numbers right here, my vertical distance and my horizontal distance. Because again, what I'm trying to find is the direct distance from A to B, and that's my value for D. Okay? And once again, just like yesterday, what shape did we form on this graph? A triangle. What type of triangle? What is it called when you got a triangle like this? A right triangle. That'll come back up next week. We're not going to worry about the triangles today too much. You see it on your worksheets, I bet. So now that we have these two numbers, right? We're going to do 3 things to them. And again, it's the exact same thing we did in the distance formula. We're going to square them, we're going to add them, and we're going to take the square root. So I've got 12. And I've got 5. First, I'm going to square them. What is 12 squared? 144. What is 5 squared? 25. Everybody with me so far? Okay, I squared them. What do my steps say I'm going to do now? I'm going to add them together. What is 144 plus 25? 169. The last thing I'm going to do is what? Take the square root. Is 169 a perfect square?
Yeah.
Yep. So what is the square root of 169? 13 units. So this is like a deconstructed distance formula. We're doing the exact same thing, just in a little bit more visual way as opposed to like a mathematical, analytical way. Now you may be looking back at this and going, well, if I went from A to B, would it be any different if I went from B to A? So let's say you go up the street, you turn right, boom, you're at your friend's house, you're hanging out there for a little bit. Now you want to go home. But let's say you don't want to take these roads, there's too much traffic. From B, I'm now going to try and go down. How many units down would I have to go to be in line with A? Still 12 units. Now this time I'm turning right again, going horizontal. How many units in the horizontal direction would I have to go? Still 5. So as long as you're using a vertical line and a horizontal line, it doesn't matter which point you start at. It doesn't matter if you're going up or down. It doesn't matter if you're going left or right. You just need to find these two distances, square them, add them, take the square root. Square them, add them, take the square root. 3 easy steps once we've identified what my two numbers are. What do you guys think? Does this seem easier than what we talked about yesterday?
Yes.
Yeah? Good. I'm glad. All right. Any questions I can answer about that? That might have been our shortest notes ever. It's only like 7 minutes.